Hey AP Stat, today we're going to get right into the basics of statistics, kind of what is statistics, what are we working with, but yeah, this is the Chapter 1 Introduction. Most chapters don't have an introduction section, but this one, well, they have a very small one. This one actually gets into some details, so I want to make sure we cover this. So statistics, the science and art of data. So yeah, is this a math class? Is this a science class? Is it an art class? Probably not an art class, but kind of sciencey at times. All right, so what we're going to be able to do today, we're going to make sure we can identify the individuals and variables in a data set and classify variables as categorical or quantitative. And there's a few other things you probably should pick up as well, but those are the main goals. So first of all, statistics. What is statistics? Well, again, they've already mentioned it's the science and art of collecting, analyzing, and drawing conclusions from data. So it's kind of a field of study. Statistics isn't the way we're using it here. It's not a plural term. It's the study of, the science of collecting data and dealing with data. So an individual is the object, the person. It could be a thing, whatever we are. Is that we are interested in knowing something about. What we want to know about them is we call that the variable. So this could be like their height or weight or something like that. It would be a variable, something that varies from individual to individual. We don't really study the things that don't vary, because those things aren't interesting. What's interesting are the things that vary, that change from individual to individual. The variables, the two types we'll look at. The two types we'll look at are categorical and quantitative variables. Quantitative are the couple I mentioned, where we're dealing with a number that's actually a quantity. That can be a little bit tricky. So height, weight, those would be quantitative variables, where the number is actually a quantity. It would make sense to do math with. It can be kind of tricky every once in a while. Something like if you record somebody's zip code, or some other number, just because it's a number like a zip code, it wouldn't make sense to add up zip codes or get the average zip code or something like that. If it wouldn't make sense to take an average, then it's actually not quantitative. That actually would fall into a category. So categorical variables, where we have a label, a name for each of the different categories that we place individuals into, and that would be categorical. So like, what's your favorite color, or what is your identification for your race or something like that. So those would be categorical variables that we place individuals into. Sometimes how we define that categorical variable is, like numbers are really easy to find. Categorical variables are weird, and sometimes we kind of make them up so that we have categories. Variables take values that vary. So one thing that we often want to know about is, how do they vary? What is the distribution? So the distribution is what values does a variable take, and how often does it take those values. With numbers, it's, what are our most common numbers, things like that. How often does it take those values? But it could be also going into your categorical variables. So that's what we're often interested in when we study those variables, is what is the distribution of that particular variable. So when we're analyzing a data set, so here's an example of some raw data that were collected. Over here on the left we see, so these are our provinces. That's something, the categorical variable here, where we've recorded the province. Notice we've got some repeats there. We've got another categorical variable, gender, and then number of languages spoken. So now that's actually quantitative, so we could actually calculate an average number. And in this categorical, quantitative, and categorical. So preferred communication method is the one that they're going to go ahead and look at the distribution for here. So they've created that, and we'll look at a bunch of different ways of doing this analysis, but just to give you an idea of analyzing data, a bar graph's a nice way to look at distribution. Down here we see the values that the variable takes. All right, so they've done some analysis on this column for us. Right, the statistics is some work, and hopefully we can utilize computers to make that work easier. But they've kind of summarized this information and brought it down there. So we've got the values it takes, and then we're getting how frequently those. So that y-axis there is showing us how frequency, when we're getting how frequently those values occur. And so we see that text messaging is often the kind of most often the preferred method of communication for these individuals. So these, I don't know, Canadian individuals. I don't know exactly where this data set comes from, but all right. An example of quantitative is up here. So the number of languages spoken. And so they take that data and then they can organize that into a data. And oftentimes these pictures are best, but there are other things we can look at. And so we can see they've organized this into a dot plot, and they've got this distribution here. And so we can see the values that it takes. We see where these dots are and how frequently it takes those. A dot plot, we'll get into that, but we see those dots stacked up. It's very similar to a bar graph, but just another way of looking at it. All right, so ultimately, kind of just getting a big idea, how do we analyze data? So we you get this big table of data, and that's a tiny table of data, really. They'll be much bigger than that generally. But examine each variable individually to get an idea of their distribution, and then the next step often after that is to start to look at relationships between variables. That's when it really starts to get interesting sometimes, is how is preferred communication related to the province that somebody's from, or how is the height related to the gender, and things like that. So we'll ultimately get to that. But oftentimes you start with graphs to summarize data, and so we've got that. We'll often add numerical summaries as well, and so we'll get things down here. This is maybe a little bit different, but like the mean down here, the standard deviation, you may know what that is, minimum, quartile. We'll get to some of these things, what they mean. But we have these numeric summaries. So oftentimes the picture's the best starting point, but those numerical summaries can do things that kind of tell us what's typical, or typical variation, things like that in those data sets. All right, so that's, and then you would get to some more complex stuff of comparing those. Ultimately, once we gather this data, we want to get to this process of inference. So what conclusions, inference is kind of what conclusions can we draw about the population from our data, from our information that we've collected. So ultimately, the way that this works is we've got a population we want to understand. So that's a large group of individuals. It could be people, it could be things, it could be animals, it can be any number of things. We often can't study the entire population. Most of the time we can't do that, so we have to take a subset of that population. We take a sample from that population. We collect data from the sample, hopefully a representative sample, not a biased sample. We'll get into more with that. We perform some data analysis on that sample. And then the biggest step, or the big step at the end, and honestly this is mostly second semester stuff here, we make an inference. What from the sample, what conclusions can we draw? Recognizing the imperfection in our data, recognizing that when you get a sample it may not be perfectly representative. So that's where we start to get into the idea of, well, how far off might our conclusions be? So hopefully after all that for today, you can identify the individuals and variables in a data set and classify those variables as categorical or quantitative.